We're told the universe is expanding, that distant galaxies are sliding away from us. Yet if everything is moving apart, where is the starting point, and what lies beyond the edge that nothing can reach? The more you try to picture it, the more the image dissolves. An explosion without a center, a boundary without a wall, a motion that happens everywhere at the same time. Tonight, we'll sit with this impossible-sounding idea and ask the question that lingers beneath it. If the universe is expanding, then away from what is it drifting? Welcome back, traveler. Tonight, we drift through science. You're lying there in a dim, quiet room, maybe with headphones soft against your ears, while the glow of your screen fades gently at the edges. The world outside has slowed down, even if your mind hasn't matched its pace yet. If calm curiosity like this helps you breathe a little easier at night, you can lightly tap the like button or subscribe, not as a chore, but as a small signal that you enjoy wandering through questions no one fully knows how to answer. And if you're here because sleep feels complicated, or because your thoughts keep looping through tomorrow, it's okay. You don't have to concentrate. You don't have to follow every explanation or remember each detail. You're allowed to drift in and out, to let whole paragraphs wash past you like slow waves. This isn't a lecture. It's a place to rest your attention. It's enough just to be here, tired, curious, or simply wanting something gentle to hold your mind for a little while. Tonight we'll explore what it truly means for space itself to expand. How galaxies drift apart, not because they're flying through emptiness, but because the emptiness is stretching beneath them. We'll see how astronomers discovered this through redshifts, telescopes, cosmic microwave maps, mistakes, recalibrations, and long nights of doubt. And we'll follow the idea outward, past galaxies, past clusters, toward horizons where our instruments fail, always returning to the human hands that measured these impossible distances and tried to turn silence into understanding. So tonight, we'll walk slowly through a universe that grows in every direction at once, a universe without an outside, a universe whose expansion is less an explosion and more a quiet unfurling. There's nothing to solve here. You can simply listen while sinking a little deeper into whatever is holding you up. Dim the lights if you want. Soften your breathing. Let your shoulders fall. Whenever you're ready, we'll begin drifting outward, into the question of how everything can move apart when there's nowhere else for anything to go. On a very quiet night, if you could stand under a perfectly dark sky, the universe would still look frozen to you. Stars would hold their places. Constellations would seem nailed in place. Nothing in your senses hints that anything large is changing. And yet, over millions and billions of years, the distances between faraway galaxies grow, as if the fabric between them was slowly being stretched. The paradox begins here. Your body feels still, your neighborhood feels stable, and at the same time, everything far away is quietly drifting. To grasp that drift, imagine a long road at dusk. Cars near you move in noticeable ways, headlights passing, engines humming. Far beyond, the highway fades into haze. Now replaced cars with galaxies, the road with space itself, and your spot on the shoulder with the Milky Way. Nearby galaxies barely shift against the cosmic background. Very distant ones, though, show a steady, systematic change in their light, a subtle reddening that tells you they're receding, no matter which direction you look. That reddening is called redshift. When astronomers pass starlight through a prism, they see thin, dark lines where atoms have absorbed specific colors. In labs on Earth, those lines fall at precise positions. In light from distant galaxies, the whole pattern is nudged toward the red end of the spectrum. The farther the galaxy, the greater the shift. This isn't just a trick of the instruments. It's the universe writing a message in color. Distant places are moving away from you. Early in the 20th century, Edwin Hubble and his collaborators turned these shifts into something startlingly concrete. By measuring distances to nearby galaxies using Cepheid variable stars as standard candles and comparing those distances with their redshifts, they found a simple trend. Recessional velocity increases with distance. Double the distance, roughly double the speed. Plotted on a graph, points lined up along an upward slanting line. Space was not static. It was doing something active everywhere at once. Picture the scene on Mount Wilson a century ago. A massive telescope points toward a faint smudge. Plates of glass catch the light. Later, under dim red lamps, someone counts the tiny spots and traces the faint spectra. On paper, a few numbers are scribbled. Distance add velocity name. In that quiet, methodical work, the old vision of a fixed, eternal cosmos gives way to something more dynamic. The universe is expanding. But the question that bothers you tonight remains, expanding into what? The most common analogy is a balloon with dots drawn on its surface. As the balloon inflates, each dot sees every other dot recede. No single point on the rubber is the center of expansion. The surface itself is stretching. In the analogy, galaxies are the dots, and three-dimensional space is like the rubber. You, sitting in your room, occupy one of those dots. From every direction, very distant galaxies appear to fade away, not because they're traveling into a surrounding void, but because the rubber between you and them is lengthening. But the balloon picture carries a subtle trap. In your mind, it's hard not to imagine the air around the balloon, the room containing it, the hand holding it. That outside space doesn't exist in the real universe, at least not in the equations that describe expansion. In the actual models, space is all there is. There is no external air, no higher dimensional room. When cosmologists say the universe is expanding, they mean the distances within space-time are increasing, not that space-time is swelling into a pre-existing elsewhere. Mathematically, this behavior is encoded in solutions to Einstein's field equations. When you assume, on large scales, that matter is spread out uniformly, the equations admit expanding or contracting universes rather than static ones. These are the Friedmann-Lemaitre models. They don't place galaxies flying through space from a central explosion. Instead, the very metric that defines distance carries a time-dependent factor that grows. The yardstick baked into the fabric gets longer with time, and everything not bound by local gravity follows along. In a control room somewhere, a cosmologist tweaks parameters in a computer code: matter density, dark energy fraction, curvature. Lines on a screen shift slightly as simulated universes either recollapse, coast, chacks, or accelerate in their expansion. A good set of parameters reproduces the observed relation between distance and redshift, the patterns in the cosmic microwave background, the statistics of galaxy clustering. None of these simulations requires an outside. The expansion is self-contained, an internal rearrangement of scale. Back in your own body, the language of metrics and parameters doesn't show up as sensation. What you can feel are more modest things: the coolness of air on your skin, the pull of gravity toward the mattress, the faint rhythm of your breath. If someone told you nothing about cosmology, you might never suspect that on scales far beyond your reach, space is stretching. Your experience of here is small, sharply bounded. The universe's behavior is vast, diffuse, and almost perfectly indifferent to your immediate state. Still, the idea leaves a mark on your imagination. Once you've heard that expansion happens everywhere, you might glance at a dark window and feel an odd ache. Your room is stable, but the horizon of the visible universe is creeping outward at the speed of light, limited by how long there has been time for light to travel. Galaxies far enough away recede faster than light due to expansion. Not because they're breaking any local rule, but because the intervening space grows faster than their photons can cross. The notion that distant galaxies can recede faster than light often sounds like a violation of relativity. It isn't. Einstein's speed limit governs how fast objects can move through space, not how quickly space itself can change in size. On your scale, space-time is so nearly rigid that you can treat it like a stage. On cosmic scales, the stage itself is slowly resizing between the actors. Telescopes like Hubble and more recently, James Webb gather faint light from faraway galaxies that left when the scale factor was smaller. Astrophysicists turn that faint light into histories. By measuring redshifts and brightnesses across many galaxies, they reconstruct how the expansion rate has changed over time. Type Ia supernovae, exploding white dwarfs of nearly uniform peak brightness, serve as markers. In the late 20th century, two teams used these markers and found, to their surprise, that the expansion isn't just continuing, it's accelerating. Some unknown component, gene labeled dark energy, appears to be pushing the large-scale growth faster. If the universe is expanding away from anything, it's not a place, but an earlier pace. This realization adds another layer to your late-night question. Not only is space stretching, it's doing so in a way that future epochs will be even emptier from any given galaxy's viewpoint. Far enough ahead, many galaxies currently visible will slip beyond each other's horizons. Their light will never arrive. From that future perspective, the universe will look smaller, more isolated, even as its underlying scale has increased. Expansion, in that sense, moves everything away from a time when the cosmos was more visually connected. Right now, though, your world is still full. Streetlights glow. Other people move through their own evenings. Signals buzz silently through the air. Inside your skull, neural firings encode bills, conversations, hopes, regrets. None of these are altered by the scale factor of the universe. Expansion doesn't tug at your coffee mug or stretch your phone. Local forces, electromagnetism, chemistry, gravity on small scales, bind things tightly enough that they ignore the cosmic drift. The universe's grand gesture happens mostly in the gaps between galaxy clusters, not between you and your pillow. Somewhere between these extremes, your room and the cosmic void, the question lingers gentle and unsolved in feeling, even if the equations are clear. If everything is getting farther from everything else on large scales, and there is no outside into which it all moves, what kind of away are we really talking about? Think about what away usually means in your everyday life. If someone walks away from you, there's a visible gap, a direction, a background they move through. If a car drives away from your house, you can point along the road it's taking. Your brain is trained on this kind of motion, things sliding across a fixed stage. Cosmic expansion is slippery partly because the stage itself isn't fixed. The road is stretching, and there is no curb outside it to stand on and watch. Cosmologists describe this with a scale factor, a single function of time that tells you how big the universe is at different moments. If you imagine a grid painted on a rubber sheet, the number of squares between two dots stays the same, but each square grows. Galaxies mostly keep their positions on that grid. They're not driving through it. Instead, the distances encoded by the grid lines increase. Away, in this sense, means farther apart according to a changing ruler, not motion through a separate room. A famous analogy uses raisins in rising dough. As the dough expands in the oven, each raisin sees all the others receding. None of the raisins sits at the true center. The dough itself, messy, sticky, continuous, is what's changing. In the real universe, galaxies are more like those raisins. mostly carried along by the overall swell of space, with local velocities layered on top. The expansion is not pushing them outward into a larger kitchen. It's a property of the dough, not the countertop. This idea feels less strange if you temporarily step into the mathematics. Space, on large scales, is represented by a metric, a recipe for turning coordinates into actual distances. In an expanding universe, that recipe includes a time-dependent factor that grows. If you freeze time, you can imagine a snapshot with some arrangement of galaxies and separations. Let time run, and the same coordinate grid now translates into larger physical distances, even if the coordinates of galaxies barely change. Observations of the cosmic microwave background give this picture strong support. That faint, uniform glow, radiation left over from when the universe was incredibly hot and dense, fills the sky from every direction. Its near uniformity tells us there is no special center inside space where the Big Bang happened. The Big Bang was not an explosion at one point, it was a state of the entire cosmos, everywhere, in which everything was once closer together. Expansion is what happened to that state as time went on. The discovery of this background was surprisingly down to earth. In the 1960s, Arno Penzias and Robert Wilson were using a radio antenna in New Jersey and kept picking up a stubborn hiss they couldn't remove. They cleaned the hardware, even evicted pigeons that had nested inside. But the noise remained. Eventually, they realized it matched predictions for the cosmic microwave background, a relic from a time when the whole universe was like a glowing fog. A local hardware problem turned into evidence for a global expansion story. If you could have stood in that early fog, there would have been no empty black sky, no galaxies, no quiet corners. Everywhere would have been bright, hot, and dense in roughly the same way. As the universe expanded, that fog cooled and thinned. Regions of slightly higher density gradually pulled in more matter, eventually forming galaxies and clusters. Expansion, seen from this view, isn't an outward flight from an external origin. It's a gradual relaxing of an initially compressed state, happening everywhere at once. Your own sense of an edge comes from the environments you know, rooms with walls, cities with borders, horizons you can walk to. It's natural to picture the universe like a giant bubble in a larger emptiness. But in the standard cosmological models, space can be finite or infinite without needing an outside. The surface of a sphere, for example, is finite, yet has no edge you can fall off. You can walk forever and never encounter a wall, only your own footsteps circling back. Some versions of the universe may be spatially curved like that sphere, others nearly flat like an infinite plane. In both cases, the expansion is not into another medium. It's a change in the internal geometry. If space is finite and positively curved, its volume grows with time as the curvature stretches. If it's effectively infinite and flat, then every region you can name simply contains more and more proper distance between its far-flung parts. Outside never enters the equations. From the human side, these abstractions fold back into feelings. The idea that there's no outside to escape to can stir an odd claustrophobia, as if everything is trapped inside a vast, inescapable container. At the same time, the lack of an edge can be comforting. There is no wall your thoughts will hit, no boundary beyond which existence stops. Space, in this picture, is not a prison box. It's more like a fabric with no loose border, only patterns that grow thinner with distance. Scientists test these geometric possibilities using observations. They examine the angular size of fluctuations in the microwave background, count galaxies at different distances, and measure how structures grow over time. Tiny differences in these measurements tell them whether space is curved or flat on the largest scales. For now, the data suggest a universe very close to flat, expanding steadily, dominated at late times by dark energy. None of these findings has yet produced a hidden wall, an outside reservoir, or a fixed center. While they work, you might be lying under a ceiling that feels much closer and more solid than any cosmic horizon. The expansion rate doesn't alter the distance between your bed and your door. Still, knowing that no galaxy occupies a privileged central throne can subtly alter how you place yourself mentally. You're not on the rim of a blast, nor perched near some cosmic origin point. You're in one ordinary location inside a pattern that repeats everywhere it can. It's sometimes tempting to imagine a special vantage point that would make everything obvious. A high balcony outside the universe where you could look back and see the whole thing expanding into a larger emptiness. But by definition, such a balcony doesn't belong to the models that match our observations. Every real vantage point is inside, anchored to a galaxy or cluster. There is no external spectator, no higher room. The universe contains all the stages, all the seats, and all the cameras. You, as one of those cameras, get only a narrow field of view, a patch of sky, a handful of measurements, a set of diagrams you've seen online. Out of that, your mind tries to build a picture of an everywhere stretching fabric with no outside and no center. It's okay if the image never feels complete. The models don't demand that you hold them perfectly. They keep working whether or not your intuition keeps up. Somewhere in that gap between intuition and equation, a quieter realization starts to form. Maybe the real strangeness is not that the universe is expanding away from nothing, but that your everyday sense of motion and distance was never built to handle this kind of change in the first place. You can feel how your intuition struggles by trying a simple mental experiment. Picture two galaxies with no forces binding them together, just drifting with the cosmic flow. At one moment, they're a certain distance apart. Later, that distance has grown. There's no rocket pushing either one, no thrusters firing. If you try to imagine what they're moving through, the picture breaks. They're not sliding across a background. Instead, the background notion of distance itself has changed between them. In cosmology, it's helpful to separate two kinds of motion: peculiar velocity and expansion. Peculiar velocity is the familiar one, galaxies moving locally because they're tugged by neighbors, like the Milky Way and Andromeda slowly falling toward each other. Expansion, by contrast, is the general stretching of space that increases separations on large scales even when peculiar velocities are small. Both can happen at once, layered together. On small scales, peculiar motion can win. Far away, expansion gradually dominates. Imagine tiny boats on a slowly widening river. Each boat may paddle in its own direction. That's peculiar velocity. Meanwhile, the banks themselves are drifting apart as the riverbed widens. That's expansion. Nearby boats can still meet or collide because their paddling overcomes the widening flow. Boats very far apart, though, are mostly carried by the changing river. Asking what the river is expanding into misses the point. What matters is how distances within the water are changing. Our own neighborhood shows this mix clearly. Within the local group, gravity binds galaxies together strongly enough that they don't follow the general Hubble flow. Andromeda is actually blue-shifted, heading toward us. On even smaller scales, planetary orbits ignore expansion entirely. The sun's gravity holds them in place. Your body, held together by electromagnetic forces, doesn't feel any cosmological stretching. The expansion only really becomes visible when you step back far enough that local bindings blur into a general trend. Astronomers use the Hubble-Lemaitre law to quantify that trend. Velocity equals h0 times distance. h0, the Hubble constant, tells you how fast the universe expands per unit distance. If a galaxy is 100 megaparsecs away, its recession speed is roughly 100 times h0. Different methods of measuring h0, using supernovae, Cepheids, or the cosmic microwave background, have yielded slightly different values, leading to a modern Hubble tension that scientists are still trying to resolve. In offices and observatories, people chase this tension with a mix of patience and obsession. They recalibrate distance ladders, refine supernova light curve models, and re-extract microwave background data, looking for hidden systematics. Some hope the discrepancy will vanish with better measurements. Others suspect it might hint at new physics, perhaps a twist in how dark energy behaves. The universe isn't confused, it keeps expanding at whatever rate it does. The confusion is entirely inside our attempts to pin down the number. From your perspective, lying down and listening, that numerical disagreement might seem abstract, almost decorative, yet it folds back into the core question you're holding. The exact value of h0 determines how quickly the away grows between distant galaxies, how old the universe appears, how large the observable region is. It's like adjusting the tempo on a very slow piece of music. The melody stays the same, but its feeling over long stretches subtly changes. Another subtlety comes from horizons. Because light travels at a finite speed and the universe has a finite age, there's a maximum distance from which light has had time to reach you. That's your observable universe. Expansion further complicates this, because some regions that once could exchange light are now receding too fast to remain in contact. In that sense, away also means forever outside the reach of communication, not because a wall appears, but because the stretching outpaces any signal. If you picture this horizon as a sphere centered on you, it's tempting to think you occupy a special place. But every observer, wherever they are, draws such a sphere around themselves and sees roughly the same story. Galaxies receding, background radiation, a horizon at some distance. There is no single, absolute center to these spheres. The expansion is not away from you personally, nor away from any hidden hub. Every point participates equally on large scales. Inside galaxies, stars don't notice this grand pattern. They orbit their centers, pulled by gravity and dark matter halos. Inside stars, nuclei fuse, oblivious to Hubble constants or scale factors. Inside your neurons, ions drift across membranes along carefully regulated channels, generating thoughts and emotions. The expansion doesn't speed or slow those local processes. They're like intricate eddies in a river, whose widening is so slow that each whirlpool can pretend the banks are fixed. When you let that sink in, a curious calm can emerge. The universe's largest behavior is both vast and strangely irrelevant to your immediate sensations. You don't have to track the growth of intergalactic distances to breathe, to rest, to exist. The equations describing expansion can be hard to visualize. Your nervous system isn't built for them. It's built for softer cues, the weight of a blanket, a dimming screen, the gradual unwinding of tension in your shoulders, and yet knowing even a little about expansion gives a kind of spacious backdrop to those cues. Your room sits inside a galaxy that's part of a web that's participating in a slow, relentless stretching of distances. When your thoughts feel cramped, it's not because space is crowded. The cosmos is making more room all the time, though not in any way you can pack a suitcase for. The away that galaxies drift toward is more abstract, but no less real. You can think of it, if you like, as the universe gradually redrawing its own map, not adding new territory beyond an edge, but increasing the scale of the existing chart so that any two far-flung points grow farther apart on the paper. Your life happens in one tiny region of that map, a cluster of marks so dense you can barely separate them. Far outside that cluster, the grid lines keep stretching, unconcerned with how crowded your little corner feels. Somewhere in that image, the original question softens without fully disappearing. If expansion is not motion into an outside, but a change in the relationships between things inside, then away stops being a destination and becomes a shifting pattern. Galaxies drift apart not toward a place, but into a future where the scale between them has grown. What that means for you lying there tonight is something we can keep unfolding slowly as the story continues. It helps to return for a moment to the earliest times we can meaningfully describe. Imagine the universe when it was less than a second old, dense, hot, and so uniform that no galaxy, no cluster, not even the concept of space between things, had meaning yet. In that state, expansion wasn't a process happening within the cosmos. It was the cosmos coming into being under new rules, cooling as it grew. Asking what it expanded into then is like asking what your shadow leans on to exist. The question feels natural, but the framework beneath it is misplaced. As time passed, microseconds, milliseconds, minutes, the universe thinned and cooled enough for distinct particles to form, then atoms, then eventually, after hundreds of thousands of years, regions where gravity could begin sculpting structure. The expansion never paused. It simply slowed, then later accelerated again. Throughout these transitions, there was never an outer chamber holding the whole thing. There was only this interior rearranging itself in scale and density. The idea of an outside horizon belongs to maps and rooms, not to the fabric of space-time. You can picture it like a melody that begins quietly and gains complexity as instruments join, even though the song never departs from itself. Early expansion was the soft opening chord, simple, pure, unlayered. As elements formed, radiation decoupled and matter clumped together, more instruments entered, each adding texture, but never stepping outside the song. The universe didn't expand into silence. It became its own evolving sound. One of the most striking signatures of this early era is the cosmic microwave background. Satellites like COBE, WMAP, and Planck have mapped its faint fluctuations with increasing precision. These tiny temperature variations, tens of millionths of a degree, correspond to the seeds of all later structure. By analyzing the size and distribution of these fluctuations, cosmologists infer the geometry, composition, and expansion history of the universe. The background doesn't come from beyond everything. It comes from a time when everything was too dense and bright to let light travel freely. Picture researchers clustered around computer screens in a dim lab, eyes narrowed as they compare predicted patterns with actual sky maps. A mismatch of a fraction of a percent can send them down weeks of recalibration. They tweak foreground subtraction models, account for galactic dust, recheck antenna noise. This painstaking work distills into a few key parameters: matter density, dark energy density, curvature. Adjusting these subtly shifts the expansion history, how fast distances grew at different epochs. No parameter describes an external room, all describe internal dynamics. Sometimes, to illustrate the idea of no outside tech, cosmologists use the analogy of a two-dimensional creature living on the surface of an inflating balloon. The creature can measure distances, angles, and curvatures, but has no concept of the surrounding air. We are, as three-dimensional beings, see the balloon expanding in a larger space, but the creature doesn't need that higher dimension to account for what it sees. For the creature, expansion is a change that happens entirely within its world. Our universe behaves similarly, but with one important twist: we can't step outside to watch. Your intuition naturally rebels. If something grows, shouldn't there be somewhere it grows into? But consider the way angles on a sphere behave. Lines that appear parallel on a small patch eventually meet if extended far enough, not because space drifts into something else, but because the space itself has curvature. Expansion is a different, time-dependent feature of the metric, but the same principle applies. The geometric rules alone determine how distances evolve without appealing to any external container. On the scale of your life, this geometry doesn't intrude. You navigate with straight lines, right angles, and stable distances. You don't feel the curvature of Earth unless you travel far enough. You don't feel cosmic expansion unless you look across billions of light years. The deep architecture of space-time rarely intersects with your daily coordinates. Yet quietly, you inhabit a space-time where the metric is stretching, even if your feet never detect it. Think for a moment about how alien that must be to your nervous system. Evolution shaped your intuition to handle falling apples, moving animals, shifting weather, not expanding space-time. So when you lie back and try to picture galaxies drifting apart without motion through an external void, the image slips away. This is not a failure. It's your brain reaching the edge of concepts it was never designed to hold. The universe is not obligated to feel intuitive at human scale. What you can feel is a kind of imaginative spaciousness. Once you let go of the need for an outside, the universe becomes a self-unfolding landscape. Galaxies glide apart like lanterns carried by a breeze that comes from nowhere and goes nowhere. Space is not contained. It simply is, and its size is one of its changing properties. Your mind might resist the idea, but some deeper part of you may find comfort in it. A cosmos without walls is also a cosmos without confinement. Measurements from baryon acoustic oscillations, faint ripples in galaxy distributions, confirm this expanding geometry across billions of years. They act as a standard ruler imprinted by sound waves in the early universe. By tracking how large this ruler appears at different distances, astronomers reconstruct how the scale factor changed over time. Again, the data points inward. Expansion is about internal distances, not external motion. More space emerges between things, not from outside them. Meanwhile, in laboratories on Earth, atomic clocks tick with extraordinary precision. Their synchronized rhythms allow us to measure the tiniest gravitational and relativistic effects. If space were stretching locally at rates comparable to cosmic expansion, these clocks would betray it. They don't. Bound systems ignore expansion because internal forces dominate. Expansion happens in the vast, delicate spaces between gravitationally cohesive islands. Your world, embedded within one of these islands, floats on a very calm tide. Noticing that calm is strangely grounding. The universe expands dramatically on the largest scales, yet your cup of water stays still. Your walls don't drift apart, and the stars in your night sky remain nearly fixed throughout your lifetime. You can let the cosmos be wild while your life remains gently ordinary. Expansion doesn't ask you to understand its mathematics before you sleep. It only asks you to accept that not all motion resembles the things you've seen, and so the idea that once felt paradoxical, an expanding universe with no outside, begins to loosen its grip. There may still be questions that tug at you, questions that hover at the edge of understanding. Sometimes those open questions are invitations, not barriers. The universe doesn't mind if you hold them lightly, the way you might hold a thought just before drifting off. Sometimes the easiest way to feel cosmic expansion is to imagine running the film backward. Instead of galaxies sliding apart, picture them drawing closer across billions of years. Clusters thicken, filaments tighten, the night sky grows brighter with every direction packed more densely with light. Keep rewinding, and there comes a point where no empty gaps remain at all. Only a hot, uniform soup, not a dot in space, but a state of space itself everywhere. Forward from that state is what we call expansion. As you follow that mental rewind, the idea of a central explosion starts to look less useful. A conventional blast has debris moving out through air from a single spot. Here, there was never air around the event, never a pre-existing room. Instead, what we think of as the universe simply occupied a denser, hotter configuration. The equations describing that regime say nothing about an external basement. It expanded inside. They only describe how density and curvature changed within. Even the phrase Big Bang can be misleading. It suggests a bang you could watch from the side, with a clear before and after. But in the models, time and space themselves are part of what emerged and evolved. Asking, what was it banging in, is like asking where the edge of a number line is printed. The line is the thing, the paper beneath it is a convenience for your eyes. Cosmological expansion is more like the line than the page. To get numbers out of this story, physicists take Einstein's field equations and assumes at large scales that the cosmos is homogeneous and isotropic, roughly the same everywhere and in every direction. Those assumptions produce the Friedmann equations, which relate the scale factor's evolution to the density of matter, radiation and dark energy. Each component pushes or pulls on expansion differently. Matter slows it, radiation did so more strongly in the past, and dark energy accelerates it. All of this is internal bookkeeping. Data come from many fronts. Type Aya supernovae trace how brightness falls off with distance, revealing accelerating expansion. The cosmic microwave background encodes early universe conditions. Large-scale galaxy surveys show how structure grows. Together, these observations point to a universe where about 5% is normal matter, roughly a quarter is dark matter, and the rest, about 70%, is dark energy. That last ingredient doesn't behave like stuff. It acts more like a property of space itself, pushing expansion faster. You can picture dark energy, imperfectly, as a gentle pressure built into the vacuum. Not a pressure trying to explode something outward, but a feature of space-time that makes empty regions tend to expand. If you remove galaxies, the effect remains. Wherever there is space, this contribution to the energy density exerts its influence. Again, the away from what question doesn't land cleanly. It's more accurate to say, space has a tendency to create more of itself in between distant things. Scientists try to pin down this strange component by measuring how expansion changes over different eras. Does dark energy behave exactly like a cosmological constant, a fixed energy per unit volume, or does it evolve with time? Observations so far are consistent with something very close to constant, but small deviations remain possible. Teams compare models, analyze error bars, and publish careful graphs with shaded bands of uncertainty. Behind each line is someone who has spent years trying to hear a whisper in noisy data. For you, lying still, the notion that emptiness has properties might sound oddly poetic. The spaces between things are no longer just nothing. They have a texture that quietly determines the future of everything large. On human scales, gaps feel passive, the air between you and the wall, the void between stars. On cosmic scales, the in-between is where expansion lives. What looks like absence in your daily life is, at the deepest level, part of the engine of change. It can be unsettling to realize that the universe appears to be heading toward a future of thinning connections. Over enormous spans of time, galaxies not tied together by strong gravity will drift so far apart that their light can't bridge the distance. From any given galaxy's perspective, the sky of visible neighbors will grow emptier. In that remote era, expansion will have carried each island of stars into a kind of solitude, surrounded by a darkness that once contained vibrant structure. Your own solitude, if you're feeling any tonight, operates on a much smaller canvas. A quiet room, perhaps a phone face down, messages unanswered. Yet there's a strange resonance between these scales. The same cosmic rules that predict lonely galaxies also allowed enough time and stability for life to arise here. The universe is gently pulling far-flung things apart, even as it has given local pockets the chance to become briefly, intensely connected. Both tendencies coexist in the same expanding fabric. Sometimes, thinking about this slow drift can soften the edges of urgency. Many of the pressures you feel are about shrinking timelines, things that must be done now, futures that seem to close quickly. Expansion tells a different story. On large scales, the universe stretches its events over billions of years. Structures grow and dissolve in immense slow motion. You occupy a tiny sliver of that timeline, hypersensitive to abrupt change, while the cosmos itself rarely hurries. If your mind insists on visualizing an outside, you might gently redirect it toward a different image. Instead of a balloon in a room, imagine a pattern on an endlessly scrolling fabric. The design stays similar, but the scale of the weave gradually increases. No border appears, no loom edges frame the view. You see more space between motifs, yet nothing is moving into a beyond. The expansion is a change inside the cloth, not an escape from it. In research centers, cosmologists continue to ask if this picture is complete. Could there be additional fields, extra dimensions, or subtle modifications to gravity that alter expansion? Upcoming surveys and telescopes are designed to test these possibilities, to sharpen the story of how a way grows with time. But even if the formulas change in detail, the core idea persists. The universe's expansion is about relationships between points inside, not a flight from an exterior void. All of this leaves you with a very different kind of away than your senses are used to. It's not a destination you could travel toward, not a location that exists independently of the things moving. It's a stretching of the intervals themselves, gradual and impartial. Galaxies participate because they have no choice. You, uniquely, can step back in your mind, feel both the strangeness and the calm of that picture, and wonder what it means for a small life lived inside a universe whose default motion is gentle separation. There's another layer of strangeness hiding in the idea of expansion. What if the part of the universe we can see is only a small patch of something larger, maybe even infinitely large? In that case, the question, away from what, twists again. If space extends without bound, then there is no outer edge to move toward, only ever more of the same fabric. Expansion doesn't push a finite bubble into emptiness, it dilates an already vast, perhaps endless canvas. On an infinite line, you can pick any point and call it here. Distances to other points can grow or shrink, but the line itself has no border. Some cosmological models treat space like that, infinite, roughly uniform, and expanding everywhere. The observable universe, a sphere defined by how far light has traveled since the Big Bang, is then just a local window. Beyond that window, more regions continue in every direction, receding too fast for their light ever to reach you. Inflation theory adds yet another twist. According to this idea, in the earliest fraction of a second, the universe went through a brief, enormous burst of accelerated expansion. Tiny quantum fluctuations were stretched to cosmic scales, seeding the structures we see today. Inflation helps explain why the universe is so uniform on large scales and why its geometry is so close to flat. But some versions suggest that inflation may continue in distant regions, creating a vast patchwork of bubble universes with different properties. If something like that is true, then your observable universe is just one bubble among many, each with its own history of expansion. From inside your bubble, you can describe how distances grow, how dark energy behaves, how structure forms. But the question away from what may not have a single global answer. Expansion could be a local story within a larger, ever-foaming landscape. And again, all of this remains internal. There is still no defined outer room containing the froth. In a sense, these models push your intuition twice. First, they remove the familiar outside, then they remove the comforting idea that everything is what you can see. You're left in a middle position, not at the center of the universe, not at the edge, but in a limited observational bubble inside something larger that may be infinite or wildly varied. The mind resists this because most of your experiences have clear boundaries, walls, shores, horizons you can walk to. Researchers explore these possibilities with tools that look surprisingly mundane. Equations scribbled on whiteboards, simulations running on supercomputers, statistical comparisons between theory and observation. They ask whether subtle patterns in the microwave background or in the distribution of galaxies could betray the shape and size of the larger space. So far, the universe has been quiet on many of these questions, offering hints but no definitive map of what lies beyond your horizon. There's a humbling asymmetry here. The universe, whatever its full extent, already knows its own structure simply by existing that way. Every region is just the way it is, whether infinite or bounded, simple or wildly varied. You, inside one small region, have to work hard to infer any of that from faint signals and partial clues. Your ignorance is not a flaw in reality. It's just a consequence of living on one world with finite time and limited tools. This gap between the universe's effortless completeness and your partial view can feel like a wound or a gift, depending on the night. On some evenings, not knowing what lies beyond the observable sphere can feel like a pressure in the chest, a reminder of how small and blind you are. On others, the same mystery can feel like room to breathe. You are not required to hold the whole structure in your mind, only to inhabit your corner honestly while you're here. Once you step back from the diagrams, the emotional meaning of a way changes too. Galaxies receding at enormous speeds become less about loss and more about participation in a shared, silent process. Every cluster, filament and void, is carried along by the same underlying rules, whether or not any conscious being is there to name it. You are not watching the universe go away from you personally. You are part of a system where everything is slowly, evenly relaxing from a denser past. In that light, distance takes on a gentler character. On human scales, distance can feel like separation, a loved one far away, a place you can't return to, a future that seems unreachable. On cosmic scales, distance is often just a record of time past since light set out. The farther a galaxy's light has traveled, the more expansion has stretched its wavelength. Far away becomes another way of saying long ago, written in color. That same logic folds inward. The events in your life that feel most distant are often the ones that happened when the person you were then is no longer quite the person you are now. The expansion between those versions of you isn't a physical stretching, but a widening of experience, perspective, and memory. There is no outside those versions are moving into, just a changing relationship between who you were and who you've become. Cosmic expansion reminds you that change in relationships can be smooth, relentless, and impersonal without being hostile. Galaxies don't accuse each other of drifting away. They simply follow the geometry they inhabit. On your scale, it's more complicated. Feelings, expectations, promises. Still, the underlying lesson remains. Not all growing distance is a failure. Sometimes it is just what happens when time passes and contexts shift. The universe has been practicing that kind of letting go for nearly 14 billion years. Meanwhile, the tools you use to glimpse these truths, telescopes, detectors, equations, are themselves tiny, fragile constructions on one planet. In a control room, someone might be adjusting a mirror, cooling a sensor, or debugging a simulation while you listen. Their efforts trace thin lines of understanding into a darkness that would otherwise remain purely indifferent. The expansion doesn't slow because we study it, yet the act of studying it transforms what it feels like to live inside it. As you lie there, you don't need to decide which grand model is ultimately correct, or whether the universe is infinite, curved, or part of a larger multiverse. The essential strangeness is already enough. Space itself is stretching, not into a larger container, but as a change in its own internal scales. The away that galaxies are headed toward is not a place with a name. It's a future geometry still unfolding, one that you, briefly and quietly, are sharing from the inside. The deeper you travel into the idea of cosmic expansion, the more you notice that something unseen is orchestrating much of it. Not gravity, which tries to pull things together, and not matter, which clumps into stars and galaxies. Something quieter, smoother, and far stranger is at play. You might imagine it like a faint pressure in the fabric of space itself, a pressure that doesn't push against anything in particular, but simply urges space to make more of itself everywhere at once. If you picture yourself drifting through a calm, dim region between galaxies, the stillness feels misleading. There is no wind, no ripple, no directional cue that anything is changing. Yet the separation between the galaxies around you slowly widens, almost as though the silence itself is expanding. That sensation captures, in a human way, what physicists struggle to quantify. Dark energy. A presence that accelerates the universe's growth without revealing its nature. The simplest model calls dark energy a cosmological constant, a uniform energy density that remains the same even as the universe expands. If that's true, then more space means more dark energy volume, and more dark energy volume means stronger acceleration, a feedback loop, subtle but relentless. The mind resists this because we're used to things weakening as they spread out. This does the opposite. It grows fiercer as the universe grows larger. You might think data that's strange came from some exotic cosmic event, but its most powerful evidence arrived as faint patterns in the light of exploding stars. Type Ia supernovae, spotted by astronomers comparing distant and nearby events. These supernovae act as standard candles, meaning their brightness tells you how far away they are. Observations in the late 1990s revealed that distant supernovae were dimmer than expected, implying that the universe's expansion had begun speeding up. Nobody was prepared for that. Imagine the scene in those labs, researchers checking calibration files, arguing over detector noise, scrutinizing atmospheric distortion. Every possibility was considered before accepting the idea that the universe itself might be accelerating. It wasn't a romantic eureka moment. It was a slow, careful surrender to what the data insisted. The Nobel Prize that followed didn't celebrate certainty. It celebrated persistence despite disbelief. Dark energy has no texture you can touch, no color you can see, no smell or sound you can describe. It's more like a mood in the universe that refuses to change. And yet, its mathematical fingerprints appear everywhere. In galaxy surveys, in microwave background measurements, in gravitational lens distortions. It is as if the cosmos leaves faint smudges of its intention on every mirror we hold up to it, though the source remains hidden behind the reflection. To visualize it more intimately, Think of stretching a soft sheet of fabric with your hands. As you pull, every point on the sheet moves away from every other point, not because the points themselves changed, but because the sheet's geometry altered. Dark energy behaves like a force acting on that sheet from below, smoothing it, coaxing it to extend. There is no direction of expansion because the sheet expands everywhere. This leads to a counterintuitive revelation. Galaxies aren't moving through space, the way a ship moves through water. Instead, the space between them grows. That's what the universe is expanding away from. Not a location, not a central point, but from the past itself, from earlier versions of its own structure. The question away from what dissolves into away from when. There's a fragile comfort in this idea. As you lie there listening, your body feels settled, unmoving, grounded in a moment. Yet everything beyond your ceiling, beyond your atmosphere, is stretching subtly without pause. You are anchored in stillness while the universe rehearses change on a grand scale. The contrast doesn't threaten you. It simply reminds you that not all motion requires noise or urgency. Still, the mystery deepens. If dark energy dominates the cosmos, will galaxies eventually drift so far apart that each becomes isolated, unable to see or influence its neighbors? Some scenarios predict a future where the night sky grows emptier, where cosmic structures become lonely islands adrift in an ocean of expanding space. There is something both sorrowful and serene in that picture, the universe exhaling forever, slowly thinning into quiet. In modern observatories, teams continue searching for deviations that might reveal whether dark energy is constant or dynamic, perhaps even a temporary phase. Precision instruments measure tiny differences in galaxy clustering, while space telescopes study the fading whispers of ancient light. Researchers debate models that shift like tide lines on a chalkboard, erased and redrawn with every new data set. The mystery refuses to collapse into a simple answer. And through all of this, dark energy feels less like a force and more like a rule of existence, a requirement the universe obeys without remembering why. You can sense the loneliness of that idea, a cosmos compelled to expand, compelled to move away from itself, compelled to create distance without agency or intention. It isn't going anywhere. It's simply becoming more of what it already is. If you breathe slowly and picture that process, expansion begins to resemble the soft spread of ink in water, quiet, inevitable, and strangely beautiful. Not violent, not chaotic, but patient. The universe doesn't tear itself apart, it relaxes. And in that relaxation, everything drifts into new relationships with everything else. But a delicate question lingers beneath the surface of all this. If dark energy guides the universe outward, what guided it before dark energy took hold? Where did the first push come from? And does it still echo somewhere we haven't learned to listen yet? Long before dark energy began to dominate, the universe's story was driven by different players. In the first fractions of a second, everything was packed into a state so dense and hot that words like galaxy or even atom didn't apply. Radiation and particles jostled in a roiling plasma, and gravity responded not to stars or planets, but to sheer energy density. Expansion then was less a gentle push and more a rapid uncoiling, like a tightly wound spring suddenly allowed to loosen. To make sense of those first instants, physicists propose an even earlier phase called inflation, a brief burst where space itself may have expanded at an almost unimaginable rate. Tiny quantum jitters, normally confined to microscopic scales, were stretched to cosmic size, becoming the seeds of all the structure you see today. In that picture, the first push wasn't a shove from outside, but a moment when a strange field rolled down its own energy landscape and released its grip. You can imagine inflation as a ball perched high on a smooth hill in a dark landscape. While it sits there, its potential energy dominates, driving an almost explosive expansion. Once the ball rolls down into a lower valley, inflation ends, and the universe reheats, filling with particles and radiation. None of this requires an external hand to flick the ball. The field and the hill are part of the same internal rules that later govern stars, galaxies, Truce, and you. Evidence for something like inflation hides in the cosmic microwave background. The pattern of temperature fluctuations, how big they are, how they're distributed, matches what you'd expect if quantum ripples had been stretched across the sky. Experiments like WMAP and Planck have mapped these patterns in exquisite detail, turning random-looking speckles into a fossil record of the universe's first moments. Hidden in that mottled glow is the memory of a time when expansion was so fast that distances doubled in a heartbeat. In conference halls and late-night Zoom calls, cosmologists argue over which version of inflation, if any, is right. Different models predict slightly different patterns in the microwave background or subtle fingerprints in the polarization of that ancient light. Some hope to find primordial gravitational waves, faint ripples in space-time itself, left over from the inflationary rush. So far, hints have come and gone, like ghost footprints that fade when you look too closely. The first push remains suggested, but not yet fully pinned down. From your bedside, these technical debates feel distant, like muffled voices in another room. What reaches you is the outline. There was a time when expansion was much faster and more violent than today's gentle acceleration. The universe has passed through phases: radiation-dominated, matter-dominated, dark energy-dominated, each setting the tempo for how a way changes. It's not one push, but a sequence of regimes, each handing the baton to the next in a long, intricate relay. There's something reassuring in that layered history. The cosmos has already survived extreme densities and temperatures, wild shifts in behavior, and vast rebalancing of its contents. Against that backdrop, your own transitions, new jobs, endings, beginnings, quiet reinventions, are small but not trivial. They are the local, human-scale echoes of a universe that has always been capable of becoming something different from what it was a moment before. Think of how your life has had its own inflationary bursts, brief periods where change happened so quickly that you could barely track it. Moves, crises, breakthroughs, intense learning phases. Later, things slowed, settled into a more predictable expansion of days and weeks. Then sometimes a new field enters, an idea, a person, a decision, and the pattern shifts again. No outside agent is needed. The ingredients for transformation were already present inside you. In the same way, the universe's early behavior doesn't require a wall to push against or a larger space to expand into. Its rules contain their own triggers and transitions. Fields change states, energy densities drop, different components take turns steering the dynamics. Asking what was outside all this may be less productive than asking, what were the internal conditions and how did they evolve? The story becomes less about escaping a container and more about unfolding from within. Still, the question of beginnings refuses to vanish entirely. What set the initial conditions? Why this set of fields, this amount of energy, this balance of laws? Physics can describe how one moment leads to another, but the very first line of the script remains blurred. Some theories suggest cycles of expansion and contraction. Others imagine before as meaningless, with time itself starting at a kind of boundary. None of these options are fully comfortable. You might notice how similar this feels to questions about your own origin. You can trace habits back to childhood back to family stories, those stories back to older histories. Eventually, you hit a point where explanation thins out. Why these people, this place, this particular thread of events? There's no satisfying outside answer, only the recognition that you find yourself already inside a script that began before you were aware of it. Perhaps that's where the emotional weight of away from what really lives, not in the physics, but in the desire for a frame that holds the whole picture. A wall you can lean your mind against, a background that makes the foreground feel secure. Cosmology whispers that there may be no such external frame, only an interior that is all there is. That can feel like standing in a room with no visible walls, unsure where anything ends. And yet, within that wallless space, there are still local structures you can trust. Gravity keeps your feet on the floor. Chemistry keeps your cells intact. Social ties keep you tethered to other minds. You don't need to answer what the universe is expanding into in order to feel a pillow under your head or hear a familiar voice. Those immediate anchors are as real as any equations scrawled on a blackboard about the early universe. If you let the unanswered questions sit beside the answered ones, without demanding that they resolve tonight, they can lose some of their sting. The first push may remain mysterious. Dark energy may stay faceless. Inflation may never be seen directly. Still, the fact that such concepts exist at all means that a small patch of the universe has learned to ask very long-range questions while lying still in the dark. That patch is you. And once you see yourself that way, as a brief, curious fluctuation inside an ancient, expanding field, another, softer question begins to form at the edge of your thoughts. If the universe can carry so many open mysteries and still go on unfolding, how many of your own unanswered whys might also be allowed to simply exist, without stopping your life from quietly expanding around them? There's a certain quiet sadness that can creep in once you really accept what expansion implies. The galaxies sliding away from one another will never come back together unless gravity in some region is unusually strong. Structures that are not already bound will only grow farther apart. On the largest scales, history is one of thinning connections, of brightness spreading over more and more emptiness. It's hard not to see a reflection of that in the way people sometimes drift out of each other's lives. From a physical standpoint, the universe may be heading toward what's often called heat death. Not an explosion or a dramatic end, but a long fade into uniformity. Energy spreads out, temperature differences vanish, and useful work becomes harder to extract. Stars burn their fuel, stellar remnants cool, processes slow. It's less an apocalypse and more a dimming. The cosmos doesn't end in fire so much as in a kind of infinite exhale, stretching into a nearly featureless calm. Your own life is compressed into a tiny, bright interval compared to that drawn-out future. Personal timelines come with sharp edges, beginnings you can date, endings you can't quite picture, but know are somewhere ahead. Against the prospect of an endlessly expanding universe, that brevity can feel almost unfair. Why should consciousness show up only for a moment in a cosmos that continues, mechanically, for uncountable ages without anyone there to watch? When you think about your memories, they already behave like a smaller version of this thinning. Early years blur, specific days vanish, only a few intense moments stay vivid. Feelings that once seemed unbearable soften. Joys that once felt overwhelming fade into warm traces. What remains is a more uniform background of "this was my life," with scattered brighter points. Entropy, in its psychological form, gently smooths even your inner universe over time. Yet those scattered points matter enormously from the inside. A single conversation may change the direction of decades. One unexpected kindness can alter how safe the world feels. In a cosmic ledger, these events leave no visible mark. They don't affect expansion, don't shift galaxies, don't register in the microwave background. But to the only mind that experienced them, they can be as defining as a galactic merger is to a cluster of stars. It's tempting, knowing all this, to slide into a kind of resignation. If the universe will expand toward near emptiness, and my life is a brief flicker inside that process, why strain to do anything at all? The equations offer no answer. They simply describe what happens to matter and energy. Meaning isn't a quantity they track, it doesn't appear in any conservation law. It's something that arises only when a patch of matter develops the capacity to care. Consider how rare that caring might be. We don't yet know how often life arises, how frequently it becomes self-aware, how many civilizations, if any, share your era. It's possible the universe is full of minds. It's also possible they're scarce. Either way, in this one spot, at this one time, there is at least one nervous system that can lie awake and feel both the ache of its own smallness and the strange comfort of being part of something vast. The expanding universe can make your worries look tiny, but it doesn't make them unreal. Anxiety about tomorrow's tasks, about relationships, about money or health, sits on a scale where they are undeniably significant. You're not wrong to feel them. They occupy most of your immediate horizon. The trick, if there is one, is to let that horizon occasionally open onto the larger one, not to erase your concerns, but to soften their grip by placing them in a wider frame. When you imagine distant epochs where galaxies drift beyond each other's reach, you might feel a pang of loneliness on behalf of future observers, cut off from the wider cosmos. But then you remember that right now, you live in a time when the sky is still rich, when the cosmic web is still visible in principle, when light from the early universe still washes over your world. You're inhabiting a brief window when the story remains legible. This realization can invert the melancholy. Instead of seeing yourself as unlucky to exist in a universe that will one day be mostly featureless, you can see yourself as fortunate to exist during a phase when the universe is knowable in this way. You are a temporary witness to a transitional era, when expansion hasn't yet erased the evidence of its own beginnings. That doesn't show up in textbooks, but it can quietly change how the night sky feels. The same expansion that will one day isolate galaxies has already given you room to exist at all. A universe that never expanded from its dense early state would have remained too hot and chaotic for atoms, let alone planets and stories. The dilution of matter, the cooling of radiation, the opening up of space, these are the reasons there is a bed to lie on, air to breathe, and enough quiet for questions to arise. Loss and possibility are entangled from the start. You might think of your life as a small bright knot in this fabric, finite, fragile, and yet intricately tied into the larger weave. Expansion ensures that the weave as a whole will grow looser over time, but it doesn't undo the fact that the knot existed, held its shape for a while, and touched nearby threads. The universe doesn't archive that pattern in any permanent way. Still, for as long as you remember, and for as long as those you affect remember, it's real. It's okay if this mix of grand and intimate time leaves you with a low, nameless ache. That's a sane response to learning that you live in a universe whose default direction is outward, whose long-term plan looks like fading, and whose laws make no special allowances for your hopes. Feeling that ache doesn't mean you're failing to understand the science. It means you're letting the implications actually reach the part of you that feels. Look, though, at what else is happening right now. In one of the countless galaxies participating in expansion, on one world circling one star, there is a person listening to a story about all of this and using it not to despair, but to unwind. The same laws that predict eventual dilute darkness also describe the chemistry of your brain, the stability of your heartbeat, and the gentle heaviness in your limbs as you start to relax. Both futures are written with the same ink. Somewhere between the cosmic timeline and your personal one, a quieter question begins to form. If the universe can head toward emptiness and still, along the way, produce moments of connection, curiosity, and relief, then what kind of peace might be possible for you, even knowing how the large-scale story ends? When you return to the original question, the universe is expanding, but away from what? You can feel how much has shifted since the first time you asked it. At the beginning, it sounded like a puzzle with a hidden picture, a center you hadn't found yet, an outer space you hadn't imagined properly. Now, it starts to feel more like a lens you look through rather than a riddle you solve. The words are the same, but the weight behind them has changed. Think of all the places your mind has visited tonight. You've drifted from galaxies receding to the balloon analogy and its limits, from the early hot universe to inflation, from dark energy's quiet insistence to distant futures of thinning light. Each piece chipped away at the assumption that away must mean toward a place beyond. Slowly, another meaning emerged, away as into a later version of itself, away as into more separation between things that were once closer. In everyday language, away often carries a hint of rejection or loss. Someone walking away, opportunities slipping away, time getting away from you. It's hard not to smuggle that emotional flavor into cosmic expansion, but the universe doesn't use the word that way. Its away is neutral, describing changing distances and shifting curvature. The sadness, the sense of being left behind, that's the part your mind adds, trying to humanize a process that isn't about people at all. That doesn't mean your feelings are misplaced. They just live on a different layer. The same equations that describe galaxies receding can also describe the slowing of a clock in a gravitational field or the bending of a light beam near a star. None of them contain anxiety or relief. Those states arise only when a small region of matter becomes complex enough to care about its own passage through time. You occupy one of those rare regions, which is why the question matters to you at all. Imagine holding a small warm stone in your hand while standing under a cold and starry sky. The stone is your life, limited, solid, tangible. The sky is expansion, vast, distant, indifferent. Both are real. Neither cancels the other. You don't need the sky to bend closer for the stone to matter, nor do you need to forget the sky to feel the heat in your palm. The trick is learning to let both exist in your awareness without one invalidating the other. On the scientific side, the work continues. New telescopes will map ever more distant galaxies, refine measurements of the Hubble constant, search for subtle fingerprints of primordial waves, and test whether dark energy really is constant. Each improvement will adjust the numbers describing how fast away grows with distance, how quickly the cosmos thins. None of them, however, are likely to produce a simple, satisfying answer like the universe is expanding into X. The models just don't have that slot to fill. On your side, the work is different. You are not responsible for tracking every new data set or resolving every theoretical tension. Your job, if it can be called that, is gentler, to decide what it means to live in a universe whose large-scale motion doesn't revolve around you, yet still nourishes a small patch where you can think, feel, and rest. That's not a task cosmology can solve for you. It only sets the stage. When you bring your attention back to your body, the contrast sharpens. Your chest rises and falls at a pace utterly disconnected from cosmic timescales. Muscles loosen or stay tense, depending on the day you had, not on the value of the Hubble constant. The expansion inside you is more about the loosening of clenched thoughts. the widening of perspective just enough that worries become manageable rather than overwhelming. Space out there grows slowly. Space inside can open in a single breath. It's interesting how often language mirrors physics without knowing it. You say you need space to think, space from a situation, space from constant noise. You talk about expanding your horizons, stretching your comfort zone. None of this involves literal changes in cosmic geometry, but the metaphor resonates because at some level you recognize that being too compressed by demands, fears, expectations feels suffocating. A universe that expands, rather than collapses, provides a quiet backdrop where expansion in your own sense is possible. If you zoom all the way out in your mind, you can picture billions of galaxies participating in this grand, slow separation. If you zoom all the way in, you see a single person curled up in a room, letting that knowledge wash over them without needing to fix it. Between those two zoom levels, most of your life unfolds. Conversations, work, small pleasures, quiet disappointments. None of them show up in cosmological papers, yet they're the only place the universe becomes meaningful for you. The question, away from what, might never be fully replaced, but it can be gently rephrased. The universe is expanding away from earlier, denser configurations, away from a state where nothing like you could exist, away from a cosmos where light couldn't travel freely, where atoms couldn't form, where stars and planets hadn't yet woven themselves out of cooled matter. You live at the receiving end of that away, in a phase where expansion has already done enough to make room for complexity. Seen that way, the motion isn't purely a story of loss. It's also a story of release, from an early pressure cooker of energy into a spacious environment where structures can arise, persist for a while, and ask questions about their own origins. Eventually, yes, expansion may carry everything toward a quieter, emptier future. But in between those endpoints, there is a long interval of intricate pattern. Galaxies, stars, worlds, cultures, and one person right now, in the dark, listening. If you let your mind soften around the edges of the question, a kind of truce becomes possible. You don't need to banish the urge to imagine an outside. You can notice it, smile at how stubbornly your intuition wants a room for the universe to sit in, and then gently return to what the evidence suggests. There is only the inside, changing its own distances. The universe is expanding, but not away from you personally. You're simply along for the ride, on one of the many threads being pulled. Soon, thoughts about expansion will blur into other thoughts, then into the wordless sensations that come just before sleep. Galaxies will keep receding whether or not you remember any of this in the morning. The question that brought you here will still be open in some ways, still answered in others. For tonight, it's enough that you let the scale of the cosmos stretch your perspective just wide enough that your own away from what feels a little less sharp, and your body feels a little more ready to rest inside an ever-growing, ever-mysterious universe. If you could somehow step outside the universe, not just outside galaxies or beyond the cosmic horizon, but truly outside everything, you might expect to see a glowing sphere swelling into a void, like an inflating balloon. That's the picture almost everyone starts with, because our intuition has no better tools. But the moment you try to imagine this outside perspective, the image collapses. There is no vantage point beyond space, and there is no void for the universe to grow into. The balloon analogy works only from the inside, and even then only partly. When cosmologists say the universe is expanding everywhere, they don't mean space is stretching in a pre-existing room. They mean the room is the stretching. There is no empty hallway behind it, no giant darkness waiting to be filled. It's unsettling because every expansion we know, lungs inflating, cities growing, bread rising, requires an external environment, but cosmic expansion is the growth of geometry itself. Distances change without needing a surrounding framework. To picture that, imagine standing in a corridor where the floor, walls, and ceiling silently lengthen behind you and ahead of you. Your feet don't move, but the tiles under you drift apart. There is no outside the corridor because the corridor defines its own inside. Space behaves similarly. Separation increases without motion through a larger place. It's a change of internal scalings, not a migration into something else. Scientific clues supporting this come from every direction. Distant galaxies show redshift, light stretched as space stretches. Microwave background maps reveal subtle shifts that match predictions of expanding metrics. Large galaxy surveys trace cosmic filaments whose separations grow with time. None of these phenomena require an outside. They only require a dynamic geometry. The data sings the same melody. Expansion is internal. Human experiments trying to visualize this often become philosophical. Students sketch diagrams of curved surfaces, embed 2D universes in imaginary 3D spaces, draw grid lines that widen over time. Professors remind them that the embedding is optional, a visualization aid, not part of the physics. The real equations, the ones written in Einstein's field theory, describe how distances behave intrinsically. The universe doesn't need a container any more than Earth's surface needs one to be spherical. Suppose, though, that you insisted on imagining an outside just for curiosity. You might picture a hyperspace, a dimension beyond all known dimensions. But the moment you assign coordinates to that hyperspace, you're treating it as part of the universe, not something external to it. You've merely expanded the definition of inside. The universe grows to include it, and the problem resets. True outsides are slippery things. They vanish as soon as you define them. As you lie there, you can feel how strange this concept is. Your senses evolved to live in rooms, forests, streets, places with walls and edges. Your body expects boundaries. Your thoughts expect containers. It's natural to try to give the universe one too, but space doesn't behave according to human intuition. It behaves according to rules that were here long before minds capable of worry existed. Try letting the strangeness settle without solving it. Picture a map whose borders keep redrawing themselves, not because something beyond the map expands, but because the rules of distance inside it change. Rivers shift, mountains drift apart, coastlines stretch. The map grows without needing new paper. The universe is that map, except the paper is the geometry of space-time itself. There's a quiet comfort in realizing that you don't have to find an outside. The question itself dissolves once you accept that expansion is about relationships between points, not about points moving through a background. What grows isn't the universe's territory, but the distances that give that territory meaning. Astronomers testing this idea build simulations where virtual galaxies float on expanding grids. They tweak parameters, adjust dark energy models, calibrate cluster masses, and compare everything to observational catalogs. The simulations don't place the universe in anything. They only track how internal coordinates evolve. The results line up with real data again and again. No container is needed. Thinking this way can shift something inside you. You might notice how often you pressure yourself to find an external reason for your feelings, an outside source for your direction in life. But many of your internal changes, expansions, softenings, and contractions happen without external pushes. You grow from within, too. Your geometry changes, even when no one else sees the process. A universe that expands from the inside out mirrors the ways you reshape yourself. A new habit, a new understanding, a new boundary can widen your internal space without requiring permission from the outside world. Some forms of expansion are quiet and self-generated, just like the cosmos. And if you let that idea sit with you, another question begins to whisper. If the universe doesn't need an outside to grow, then what parts of your life might be able to expand even without an external opportunity, simply because the internal conditions are ready for more room? If you strip the idea of expansion down to its barest core, it becomes a story about changing relationships. Distances lengthen, horizons shift, paths that once intersected drift apart. That's true for galaxies. It's also true, in a quieter way, for people. You don't feel the Hubble flow in your bones, but you know what it's like when something that used to be close no longer is. When routines loosen, when friendships thin, when versions of yourself move out of reach like dimming stars. From the universe's perspective, none of this has emotional weight. A galaxy receding at tens of thousands of kilometers per second is as ordinary as a stone lying still. The equations treat all configurations with the same impassive clarity. But from your viewpoint, expansion feels different. It's not just about where things are, it's about what those distances mean. An extra light year between two galaxies is nothing to them. A few extra days of silence between you and someone important can feel immeasurable. You live at the intersection of these two kinds of distance. One is geometric and indifferent, measured with telescopes and rulers built from light. The other is psychological, measured in how long a message goes unanswered, how far away a version of your life feels. The universe doesn't track the second kind at all. Yet it's the one that fills your evenings, the one that makes you seek out calming stories and quiet explanations when your mind won't slow down on its own. If you imagine yourself as a point in space-time, a dot on a vast four-dimensional diagram, you're carried along by the expansion whether you notice it or not. Your world line threads through a growing cosmos, past events that are forever fixed and toward events that are not yet decided. From far away, that line would look simple. Born here, moves there, ends here. But in the cross-section of your awareness, it's anything but simple. It's layered with hopes, regrets, and small moments that never show up in any cosmic plot. Redshift can be a useful metaphor here. As light travels through expanding space, its wavelength stretches, its color slides toward the red. Information is still there. It's just been softened, cooled, made less energetic. Memories behave similarly. The further you move from an event in time, the less vivid it becomes. Sharp edges blur, intense emotions mellow. The color of the moment shifts. You still carry the imprint, but it no longer pierces with the same brightness. In astronomy, redshift tells us both distance and look-back time. How far and how long ago? In your life, something like that happens when you revisit old experiences. You can sense how far away a period feels, not in kilometers, but in the number of changes that have happened since. The more your internal landscape has expanded, the more stretched those memories become. They're part of you, yet they belong to a universe that no longer quite exists. Cosmologists use careful tools to decode redshifted light. Spectrographs, calibration lamps, long exposures. You use quieter tools to decode your own past. Conversations, journaling, late-night reflection, therapy, or simply lying awake as scenes replay themselves in softer focus. Both processes are attempts to reconstruct what happened from what remains. A spectrum here, a feeling there. The universe doesn't care whether you succeed, but for you, those reconstructions shape how you move into whatever comes next. The cosmic story suggests that some distances, once grown large enough, can never be closed again. Regions of space drift beyond each other's horizons permanently. On the human scale, it can feel that way too. People you will never see again. Paths you will never retake. chances you can't reverse. The physics and the psychology rhyme, even though they arise from completely different mechanisms. Expansion is a useful language for both, as long as you remember where the metaphor ends. There's a risk, of course, in leaning too hard on that rhyme. It can tempt you into thinking that every separation is inevitable, that every loss is written in the same stone as the fate of galaxies, but gravity still pulls things together. On cosmic scales, bound clusters persist despite expansion. On your scale, effort, care, and communication can still draw people closer, restore trust, or deepen connection. The universe is not a script that dictates your relationships, it's a backdrop that makes them possible. When you look up at the night sky, you're seeing something halfway between presence and memory. The light from many stars began its journey long before you were born. Some of those stars may already be gone, yet their photons continue to arrive, carrying evidence of a past that no longer exists, but still matters. In a smaller, quieter way, the same is true of words spoken years ago. Gestures you barely remember making, choices you've almost forgotten. Their light continues to reach people, including you. This is one way to reinterpret the original question. Instead of asking, "The universe is expanding away from what external place?" you can ask, "What is expanding away from what in me?" Maybe the cosmos is moving away from a denser past, and you are moving away from earlier states of yourself. Tighter identities, narrower beliefs, more constrained possibilities. Expansion, then, becomes not just a description of space, but a poetic lens for personal change. That doesn't mean growth is always gentle. On large scales, expansion can tear apart loosely bound structures. On smaller scales, outgrowing old patterns can feel like a kind of internal friction. Parts of you want to stay bound, other parts feel the pull of a wider configuration. The discomfort doesn't mean you're doing it wrong. It simply means you're at one of those thresholds where the geometry of your inner life is being rearranged. The universe offers no guarantee that this process will be easy, only that it will be possible. The same physical laws that allow atoms to form, stars to shine, and planets to orbit also allow nervous systems to rewire, habits to shift, and perspectives to widen. Expansion isn't just something that happens out there. It's baked into the capacity of matter to take on new forms, including forms that can question their own path. Lying there now, you don't have to resolve all of this. You don't need to decide how much of cosmic expansion you want to turn into metaphor, how much you want to leave as physics. You can simply let the images float, galaxies drifting apart in a dark web, old versions of you receding like faint constellations, new possibilities glimmering at the edge of your awareness like barely detectable galaxies in a long exposure. At some point, your attention will stop tracking these images altogether. Thoughts about away and outside will thin, like the density of matter in an expanding universe. What remains will be simpler. The feeling of a body held by gravity, the rhythm of breathing, the quiet hum of a brain that, for a little while longer, is allowed to rest. The cosmos will continue its slow unfolding, and you will, for a time, stop needing to ask what it's expanding away from, because you will finally be drifting peacefully into sleep. You've been drifting for a while now with one stubborn question as your anchor. If the universe is expanding, what exactly is it expanding away from? At the beginning, that question probably conjured an image of a bright sphere racing into a surrounding darkness, like fireworks in slow motion. Now, after walking through red shifts and horizons, dark energy and early hot phases, that first picture feels thinner. The words of the question stayed the same, but the landscape behind them quietly turned into something deeper and stranger. We followed galaxies as their light stretched toward the red, not because they were flying through a pre-existing void, but because the fabric between them was lengthening. We sat with the realization that there is no single center where a bang happened, no outer wall waiting to be reached. Expansion became less like debris from an explosion and more like a rule of geometry, distances increasing everywhere, not into somewhere else, but into later versions of the same interior. Along the way, you watched the simple balloon analogy break down. The rubber surface helped at first, then misled you with its external air and the hand that holds it. Bit by bit, the models replaced that hand with metrics and scale factors, with a cosmos that needs no surrounding room. The universe, in these equations, isn't an object in a bigger space. It is the space. Growth happens in relationships between points, not as motion through a background stage. We also moved backward in our minds, rewinding from thinly spread galaxies to a dense, glowing early state, and maybe even to an inflationary flash where space itself swelled at incredible speed. None of that required an outside push. Fields shifted, energy densities dropped, phases changed. Time and space weren't expanding inside a basement. They were part of what was coming into being. The from in away from what slid subtly from place to condition, from external container to internal starting state. Then the story tilted forward again toward a future where dark energy dominates, where galaxies not already bound drift beyond one another's horizons. Expansion began to look like a long, patient thinning, a slow increase in separation that may lead not to a dramatic ending, but to a cooler, quieter universe. That picture carried its own ache, a sense of things moving out of reach, of brightness dissolving into near-uniform dusk. Yet it also revealed how much space had to open for you to exist at all. In between those cosmic scenes, your own life kept flickering in the background. The universe's expansion became a metaphor for emotional distance, for memories redshifting into softer colors, for versions of you receding into a personal past that can't be revisited. Unlike galaxies, you still have some choice. You can reach back, reconnect, retell, build new structures. Gravity continues to bind clusters in the cosmos. Effort and care can still bind lives on Earth. The large-scale script doesn't erase your agency on the small scale. What began as a technical question gradually turned into a different kind of invitation. If the universe doesn't need an outside to grow, if it simply stretches its own interior rules, then maybe some parts of you can expand from the inside as well. New perspectives, gentler expectations, wider margins for rest might not depend on external permission. They can arise the way cosmic phases did, from conditions that finally became ready to shift. You're not separate from that story. You're a temporary configuration of the same matter that's been moving apart for billions of years. By now, it's okay if the details have blurred. You don't need to remember the names of satellites, the shapes of graphs, or the values of constants. It's enough if a few images linger, galaxies as raisins in rising dough, the early universe as a bright fog, horizons as limits set by light's long journey, dark energy as a soft insistence in the vacuum. Even if those images fade by morning, some spaciousness they opened in you can quietly remain. If you're still awake at this point, I'm genuinely glad you stayed with the story this long. Thank you for lending your late-night attention to a question most people never let themselves sit with. You could have filled this time with noise or distraction. Instead, you let the universe's weirdness stand next to your own worries for a while. And if you drifted off earlier and are only hearing this on some half-conscious level, that's perfect too. This was always allowed to turn into sleep. Before you go completely, it would be strangely comforting to know from where in this expanding universe you're listening. and what time it is where you are on this small and moving world. If you feel like sharing, you can leave a comment with your place and your hour. And if nights like this, quiet, slow, wandering through science, help you breathe a little easier, you can tap like or subscribe so more journeys like this find their way back to you. Soon, the screen will dim, the room will reclaim its darkness, and your attention will loosen its grip on questions of away and outside. The universe will keep on stretching its own distances, indifferent and continuous. You, for a while, won't need to track any of it. There will just be a body resting under gravity, lungs trading air with the atmosphere, and a mind easing out of thought into the simple fact of being here, one small, quiet observer carried gently inside an ever-expanding, ever-mysterious cosmos.